All right, so we know that in this unit we've been looking for ways to solve for missing parts in a triangle with the least amount of information. So if I don't have two sides, I can't use Pythagorean theorem. I know it's not 30, 60, 90. I can't use special rate. So now we're going to look at trigonometry. So what we have is there's actually 6 trigonomic ratios, but there's 3 main ones. And it's how the sides and the angles relate to each other, and it's in right-angled triangles. So if this is our angle, then how that angle relates to the sides. So we have 3 of them, like I said. First we have sine. Sine is opposite, so sine of my angle is the ratio of opposite of that angle over hypotenuse. So you can kind of know that if I'm here, my opposite and my hypotenuse change. But if I'm here, my opposite is here, but my hypotenuse always stays the same wherever I'm at. Hypotenuse is always straight across from that 90 degrees. So sine is opposite over hypotenuse. Cosine is adjacent, so the side next to it, over hypotenuse. And this hypotenuse can only be the hypotenuse. It stays the hypotenuse through all of them. And then tangent is opposite over adjacent. So we have those 3 ratios that we remember. And like I said, there's 3 other ones, but these are the main ones. They're just kind of in reciprocals of this one or the other ones. So the way to remember those, one way that we can remember it is some old hippie. So sine old is opposite over hypotenuse, came a hoppin', cosine adjacent over hypotenuse through our apartment. That's one way, or most often you see this SOHCAHTOA being the way that we do that. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So you're going to want to make sure you know those ratios, and then we're going to use those to find angles. When we're looking for angles, we use what's called the reverse of an angle. To do this, we use these cosine, -1, and tangent -1. This -1 just means inverse, and you only use the -1 when you're looking for an angle. So, for example, you could put in sine -1. If the sine of the angle is 0.1115, so the ratio is 0.1115, then the angle, to find the angle, I would put sine -1, 0.115 equals, and to get this, a lot of times you do shift sign or second sign on your calculator, and you should get 6.4 degrees. If you don't, you might be in radians. So let's look at it with an angle here. So here we have, and this is arrows just pointing us that this is the hypotenuse, because remember, hypotenuse stays the same. So we want to see what we have for ratios. 14, we're looking for angle C. 14 is hypotenuse. This is opposite of 90 degrees. 6 is adjacent. So we look at our 3 ratios, sine, cosine, and tangent. Goodness. That's SOHCAHTOA. And we know that we have adjacent and hypotenuse, so the one that uses adjacent and hypotenuse is cosine. So we would go cosine -1 adjacent over hypotenuse, so 6 over 14. You should get 65 degrees if I round to the nearest whole. So here again, we're looking here for this angle X. So from where angle X is, 8 is opposite. Notice this is our hypotenuse. And 3 is adjacent. so the one that uses opposite and adjacent is tangent. So tangent of my angle x equals opposite 8 over 3. So if I'm looking for the angle, I would do tangent -1 of 8 divided by 3. So shift tangent, and I should get 69 degrees. So y, we're looking for y, so from that, y 10 is opposite, and 12 is opposite of the 90, so that has to be hypotenuse. So opposite and hypotenuse go with sine, so sine of y equals 10 over 12. So we would do sine -1 of 10 divided by 12. And you should get 56 degrees. All right, so next we're going to look at finding a side when we know the angle. So again, we're relating to the angle that we're given, but we're not going to use -1 because we're not looking for an angle. So we're given this angle 30. So we're looking at how k relates to 30 and how 7 relates to 30. So k is adjacent and 7 is hypotenuse. So since we have adjacent and hypotenuse, we're going to use cosine, and we'll write it out. Cosine of 30 will equal adjacent over hypotenuse, because cosine of my angle equals adjacent over hypotenuse. So we're just filling in. Here we put the angle, here we put the variable, and here we put the ratio. Then to get k by itself, we'll multiply both sides by 7. And we have 7 cosine 30. And you could have done this with your special rate also. So we get 6.06 for my sides. Okay, let's look at one more. So 50 is what my angle I'm given. R is opposite and 4 is adjacent. So we have opposite and adjacent. So we have TOA, so tangent of 50 equals opposite over adjacent. Multiply by 4. We put in 4 tangent 50 in your calculator, and R equals 4.8. So we saw in our first activity that all these all 50, 40, 90 triangles have the same ratio and so forth, and now it's just using that to find those. I want to look at when my variable is on the bottom, when it's down low. So it's up high, we multiply. Notice when it's down low, so again we want to relate, we'll set it up. So cosine 30, we have adjacent over hypotenuse, so that's why we use cosine, 5 over x. And we can multiply both sides by x to get rid of this x in the denominator. So if x cosine 30 equals 5, and then divide by cosine 30. So some people remember that as they just switch spots because you're just kind of cross multiplying on there. So we would do 5 divided by cosine 30 equals 5.8. So x equals 5.8. All right, if you have any questions, make sure you come in.